The beauty of some questions is that they require certain inequalities that you never would have thought to be useful, especially on first glance. However, as is always the case, once you get the solution, it becomes obvious that, oh, I should have thought about in those terms because the question is based on such and such chapter or the mixture of so and so chapters. For example, here, this is a question from complex numbers, again, a previous year question from JEE Advanced, and it obviously uses the polar form. So, when you will finally understand the complete solution, it would seem that, oh, this wasn't so tough. But that's the thing, right? Because now you have known the solution, you know that you had to think on those lines. But the key is to understand that whenever you have a question that is explicitly going to be solved using the polar form, think in terms of trigonometry. So let's start doing this question. We have 10 positive valued angles in radians, and again, these two terms sound innocent, but they are very important when it comes to this inequality that we will be using, and they have defined certain complex numbers. Now, they gave two statements and we have to see whether they are true or false. So because z of k is z of k minus 1 into e raised to the power I theta k, and this is basically a complex number with unit modulus. So what this means is it has given you values of z2, z3, z4 and so on in terms of previous complex numbers. So basically in terms of z1. So you can see that z1 is e raised to power I theta 1, that is given, so mod of z1 is 1. Similarly, because all complex numbers are given in the form of z1, the modulus of all of them is also 1. They are given in such a way that the mod of all these numbers is 1. What changes is the argument or amplitude. So based on this, let us just find mod of zk minus mod of zk minus 1. Because all of these terms are written in this form, the first 9 terms, and the last term is in a different form, or it is a little different from these terms. So we will have to calculate that differently. We will come to that later, but let's just first focus on z of k minus z of k minus 1. So it will be z of k minus 1 into e raised to the power I theta k, because that is how the complex number is defined or is given, minus z of k minus 1. So you can take mod of this outside because this is a common term, this is 1. So we are left with this and we need to focus on this, cos theta k plus I sin theta k minus 1. Now actually this is a standard inequality, or I'm sorry, this is a standard modulus. You might have read this, its simplification, or you might have by hearted its simplification, but it is not necessarily required that you by heart it. Even if you have not by hearted it, you can derive it quickly. So basically this is simply finding the modulus of this term. So you will have 2 minus 2 cos theta k. You have to finally write it in terms of only one function, either cos or sine. So in this case, it simplifies in terms of sine. You have finally, when you simplify this term, you finally get here 2 sine theta by 2 k, or 2 sine theta k by 2. This is the angle theta k by 2. Okay, I don't think this is tough to understand. You can just pause it and read it. The important part comes the next thing. Now, if you have studied trigonometry, there's a very important inequality which says that mod of sine theta is always less than or equal to mod of theta. Now, basically, you are taught it as sine of theta is less than or equal to sine theta and so angle. But if you take mod, then that is valid for all values of theta. That is for all values of r. That inequality is the key to this question. So basically you have this, and so just apply mod both sides. That is the inequality, that is sine theta less than equal to theta. It has certain conditions, but this is true for all values of theta. So basically what we found here was mod of z k minus mod of z k minus 1. It came out to be this, and because this is less than theta, so this entire term, the modulus of this entire term is less than or equal to 2 times theta k by 2, because the angle here is not theta k, it is theta k by 2. This 2 gets cancelled, so the mod of this quantity is always less than or equal to theta k. So notice that is what was asked in P, right? That the terms are asked in such a way. So we have actually found a relation when it comes to these 9 terms. Okay, we will have to wait for this term. So what we have found is, since mod of zk minus mod zk minus 1 is less than or equal to theta k, you will have, when you substitute zk, when you will substitute k is equal to 2, you will get mod z2 minus z1 less than or equal to theta 2, k is equal to 3, so until k is equal to 10. So for the first 9 terms, we have found these 9 relations. Finally, as I'm seeing that this term is a little different, to focus on this term, we will notice that z2 is nothing but e raised to power I theta 1 plus theta 2. again using this relation that they have given, we are using this now to find z2, z3, z3 and to find if there is any pattern. So finally, yes, there will be a pattern. Z3 will be e raised to power theta 1 plus theta 2 plus theta t, so on. So z10 will be, you will have a sum of all of these angles, and the sum of these angles is given as 2 pi in the question itself. Here it is given that the sum is 2 pi. So very easily more, z10 is simply 1 because e raised to the power I 2 pi is nothing but e raised to the power I into 0. So z1 minus z10 mod, which we had to find, we will have e raised to power I theta 1 minus 1, and this you know how to solve, right? And finally you will again arrive at something similar, and using the same inequality you will get z1 minus z10 is less than equal to theta 1. So we had these 9 inequalities here, we had this last inequality here, and notice that is what I said right in the beginning, that this is a very important thing to note, to remember, or this is a very important point in this question, that since all of these angles are positive, you can directly add the inequalities. So we can simply add these 9 and this last one. So what we will get is, the left hand side would be what the question was asking, and is less than equal to the sum of all these angles. The sum of all angles is 2 pi. So the term, this entire term, now this entire term here is less than or equal to 2 pi. So this statement is true. Similarly, now if you will notice, we just have a factor of 2 here, and where this factor of 2 can come from this, because it is a polar form. When you raise to the power of 2, z1 square will be e raised to the power I 2 theta 1, right? Similar to similarly z2, z3, z4. So you will have to just to notice that. I won't be deriving it completely now because that is up to you, because it's the same thing. Just notice that z2 square will be, it will be z1 square, this is into 2 theta 2. So again zk square minus zk minus 1 square will be z square k1, again exactly similar, just that we have raised a power. But because this modulus was already 1, this will again be 1, and now instead of cos theta k minus 1 whole plus sine theta square whole square, we will have 2 there in that case, not in this case. Okay, so in second case you will have 2 theta k, 2 theta k, that is what I have written here. And then you take the modulus exactly similar to the previous case, and here also z1 square minus z10 square will be again the same thing, that instead of theta you will have 2 theta, here you will have 2 theta, here also you will have 2 theta, exactly same as the previous case. So when you will, and when you will take in the factor of 2 there, you will find that this statement, complete statement, is also true. So both P and Q are true is the answer to this question. And again, the game changing inequality in this question was this one. So if you would have remembered it, and as I said, the thing that could have helped you to think in terms of trigonometry is already that this question was given in polar form. So if you want to understand how to think about all the theory that you have already learned, all the questions that you have already solved, how to think in terms of what JEE requires you to think, JEE Advanced specifically requires you to think, follow this channel, watch our videos. So slowly we will start developing that thinking, because we focus more on that thinking. I believe that theory is already given you everywhere. You have books, you have coaching modules, you have so many people who have uploaded theory for free on YouTube till advanced level. You already have all those resources. But what I feel that sometimes people can miss, or students can miss, is the application. But the fun thing is, the application part is actually very fun. So you can just scroll these videos while you are free, or even while you are seriously preparing, or when you are seriously studying, you can just scroll these videos to see any previous year question and how JEE wanted you to think, and how that can improve your thinking capabilities when it comes to the exam. If you want all of that, please subscribe to the channel and watch all our previous videos. We have taken the tougher questions from JEE Advanced previous year questions one by one, and often I've seen that the solutions that are there on the internet, sometimes they are not up to the mark, because when teachers often solve them, they often solve it in a way that they have to publish the answers as soon as the question comes, right? So there's the time constraint. So you have not thought to the question, you have not thought through the answer as you would have wanted. After if you give them 2 or 3 days, they themselves will be able to come up with more compact and straightforward solutions. But because I have the liberty of time, I've revisited those questions and given you better solutions from what I feel are better solutions from what are available in most places. So you can polish your preparation in that way. Thank you.